Okay, so for your foldable, okay, so we've got a fun little foldable to create. What I want you to do, you're going to fold these in. So the negative exponents, power of a power, products of powers, power product, that should be on the outside like this. So fold into the center. There's a line there for you to fold into. And then you're going to take scissors, cut along the dotted lines. So you should end up with a foldable that has 4 flaps here. So not all of these are new rules. I don't want you to be intimidated that we have 4 rules today because we've already gone over 2 of them. So the negative exponents, we did that Monday and Tuesday. And then the products of powers, multiplying powers with the same base, that's what we did yesterday. So today we are going to talk about the power of a power. And you know what we may do? I think here's what we're going to do. I think what we're going to do today is we're going to go through, we're going to fill out almost all of the foldable except this power of a product. And let's save the power of a product rule for Monday. Okay? And so Monday we'll talk about the power of a product. So today we will just talk about the power of a power. We'll just do those examples, and then I'll tell you which problems on your homework assignment you will be able to do just using that rule. Okay, so inside your foldable, if you want to open that first flap, okay, that says negative exponents. So this one is just a review because we already know how to do negative exponents. Remember, any power that has a negative exponent is not considered simplest form. To make a negative exponent positive, flip the power over the fraction bar. So if you have a to the negative n, it is the same thing as 1 over a to the n. So if we have 3x to the negative 4th y squared. This is not simplest form because I have an x to the negative 4th. Now remember, the biggest thing with the negative exponents, you are only circling the powers that have a negative exponent. The only thing that has a negative exponent here is the x. So the 3y squared would stay in the numerator. You would flip the x down to the denominator, and the negative 4 becomes a positive 4. We are going to have negative exponents again today. So those aren't going anywhere. Now the rule from yesterday, the product of powers. Okay, so it should be the one on the right, the top right, okay? For products of powers, this is what we did yesterday, okay? When multiplying powers with the same base, you add the exponent. So if I have 3x to the 3rd times 2x to the 5th. Okay, to multiply these, we talked yesterday about kind of rearranging things. Multiply the things together that you can actually multiply together. So I can take 3 times 2. So 3 times 2 is 6. And then when you take x cubed times x to the 5th, remember we talked about yesterday that if you were to expand this out, it would be 3x's being multiplied, and then 5x is being multiplied. So that's why you take 3 plus 5, there would be an x to the 8th. You add the exponents. Now I mentioned yesterday that it's going to be really important for you to understand the why. We need to understand why we add. And all that is knowing that x cubed and x to the 5th, that's 8 of them, right? That's the why. Okay? You have to understand that because the rule today, so the bottom left-hand rule, that says the power of a power. This rule is so easily confused with the other rule. Okay, the other rule says you add the exponents. This rule says when taking the power of a power, you're going to multiply the exponents. What this looks like is you're taking a to the m to the n power. So this says you multiply the exponents. So we'll do a couple in here so I can kind of show you what this looks like. So if I have x squared to the 4th power. Okay, my rule says here you are going to multiply these exponents. It would be x to the 2 times 4 would give me an 8. Now that's the rule. That's the shortcut. But here's the why. And this is the part that you have to understand. X squared to the fourth, okay? This means you're going to multiply something by itself 4 times. Well, I'm going to take x squared, I'm going to multiply it by itself 4 times. And if you were to expand that out, it would say x squared times x squared times x squared times x squared. X squared to the 4th power, take x squared, multiply by itself 4 times. Now what's kind of confusing when I do expand this out is this is actually the rule from yesterday. Right? Multiplying powers with the same base. So you'd add the exponents, you take 2 plus 2 plus 2 plus 2, which is 8. I just told you to multiply. Because when you expand it out, you're adding the same number over and over and over again. And isn't 2 plus 2 plus 2 plus 2 the same thing as 2 times 4? Yeah. So the shortcut just tells you to multiply. So if I had, let's say we had x cubed to the 5th. X cubed to the 5th. Once again, if you were to think about this, it'd be x cubed times x cubed times x cubed times x cubed times x cubed. Multiplying powers with the same base, you take 3 plus 3 plus 3 plus 3 plus 3, but we don't want to have to do that. 3 plus 3 plus 3, 5 times would be the same thing as 3 times 5. That would just give you x to the 15. Okay, we're going to save that other rule for Monday. Okay, so let's go ahead. We can get this glued. So let's go to your table of contents, page 71. This is going to be section 7.3, and it's going to be more multiplication properties of exponents. Okay, so although we are adding just one more rule today, keep in mind the previous 2 rules, the 0 exponents and the multiplying powers with the same base, we're still going to have to use both of those, and especially the multiplying powers with the same base, where you add the exponents, and then the power of a power, where you multiply the exponents. We have to work really hard to keep those 2 rules separate and know when to apply each one. Okay, so number 1, let's say we have, in parentheses, n to the 4th to the 8th power. Okay, now this is the rule from today. This is a power of a power. We're not going to expand it out, but if you think about it, if I were to expand it out, it'd be into the 4th, times into the 4th, times into the 4th, times into the 4th, 8 times, right? So I'd have 8 into the 4ths, which would mean I would take 4 plus 4 plus 4, I would add 4 8 times, which is the same thing as taking 4 times 8, which is why you just take 4 times 8, you get into the 32nd. Now, throwing in the previous rules, what if I change this and I have n to the 4th to the negative 8? Right, it's the same thing. We just multiply the exponents, except this time it's going to be n to the negative 32nd. And if you have n to the negative 32nd, this is the rule for Monday. We can't leave it as negative 32nd. I cannot have a negative exponent. So we're going to take that power, we're going to flip it to the denominator, and it'd be 1 over n to the 32nd. Okay, now let's bring in the rule from yesterday. Okay, so number 3. What if we have n times n to the 4th to the 8th? Okay, now you kind of have to follow order of operations a little bit because I can't take n times n to the 4th because I have an exponent. And exponents come before multiplication. So the first thing I need to do is this, n to the 4th to the 8th, which is what we exactly what we just did. You're going to multiply those together, you get n to the 32nd. But then what I need to do is I need to take n times n to the 32nd. This is the rule from yesterday because I'm multiplying powers with the same base. And the rule from yesterday says I add the exponents. If there's not an exponent there, remember it's a 1. Just remember the reason why we add the exponents. I've got n, and then I've got times 32 more n's. So if you were to expand it out, which we don't want to do, and then squash it back up, you'd have 1, and then 32, you'd have 33 n's being multiplied together, which is n to the 33rd. Okay, what if we do something like, okay, let's do n cubed to the negative 5th times n squared to the negative 1st. Now, kind of like the last one. First thing, we've got to address these parentheses, which means I'm going to need to multiply these together. The power of a power, you're going to multiply these together. 3 times negative 5 will give me n to the negative 15. Times, you're going to do the same thing here. 2 times negative 1 will give me n to the negative 2nd. That's the rule from today. This is the rule from yesterday. If you're having a hard time keeping them separate, I know they're negative exponents, but pretend they're not negative exponents. If it was a positive 15 and a positive 2, you'd have 15 of them and then 2 of them. What are you going to do with these exponents? You're going to add them, and you have n to the negative 17. But I can't leave it as n to the negative 17. What do I need to do? 1 over n to the 17. Okay, let's do just a couple more of these so we can work on getting this rule down. Let's try n cubed times n to the 4th to the negative 5th. Okay, what's my first step here? What's the first thing I should do? You have to do the exponents first, okay? So we're going to do n to the 4th to the negative 5th. What does my rule tell me to do with these, with the 4 and the negative 5? This rule from today. The power of a power. This is where you multiply. You have n to the negative 20th. And we're still going to multiply that by the n cubed. Now this time, once again, if you're confused about whether you're supposed to add or multiply, think about them as positive exponents. If you had n cubed and n to the 20th and you expanded it out, you have 3 of them and then 20 of them, what would you do with these exponents? You'd add them. 3 plus negative 20 gives me negative 17. And we want to flip that to the denominator. We have 1 over n to the 17th. Yes?
Anytime it's like multiplications,
yeah, yes. If you have an exponent on the outside, right, it's raising like parentheses to a power, you are going to multiply them. I know whenever I was in school, I don't know why this just seemed to click with me. I noticed that these are like close together. See how these are closer together than like the 3 and the negative 20? I don't know why. For me, I was like, oh, you're just going to multiply those together. Okay. If that helps.
So if there's not one outside of it, then you add those when it in parentheses.
Right, yeah. So if like that negative 5 wasn't there, is that what you're saying?
Yeah.
Yeah, you would add these. Even if they're in parentheses, you're just multiplying n cubed times n to the 4th. Yeah. Okay, let's do one more. I want you guys to try. Let's try this one on your own. Let's do n to the 6th to the 5th times n cubed to the negative 4th. I want you guys to try that one on your own. All right, let's see how we did. So with both of these, you've got to address the exponent first. So I have n to the 6th to the 5th power, n cubed to the negative 4th power. You're going to do the same thing with the 6 and the 5 that you do with the 3 and the negative 4. What are you going to do with these sets of numbers? You're going to multiply them. This is the rule from today, right? I don't think that clicks with you. Multiply them together, so that's going to be n to the 30th times n to the negative 12th. Now this is the rule from yesterday. What do I do with these exponents? Add them. You get n to the 18th. Do I need to flip anything here? No, because it's a positive exponent, so we would just leave it.